Good day everyone, I am Irish Barajo, ABSN 1 Batch 3 student. And today I'm going to discuss the three mathematicians and their contribution in the world of mathematics. The first mathematician is Euclid. Euclid was one of the first great Greek mathematicians in his classic Elements. Euclid laid the framework for our formal understanding of geometry. While earlier Greek philosophers like the Pythagoreans investigated a number of mathematical problems, Euclid introduced the idea of rigorous proof, starting with a handful of assumed axioms about the basic nature of points, lines, circles, and angles. Euclid builds up ever more complicated ideas in geometry by using pure deductive logic to combine insights from previous results to understand new ideas. This process of using rigorous proof to build new results out of existing results introduced in the Elements has remained perhaps the most central guiding principle of mathematics for over 2 millennia. The next mathematician is Archimedes. Archimedes was possibly the greatest mathematician of all time. He is best known for his contributions to our early understanding of physics by figuring out how levers work and in the famous legend of his discovery of how water is displaced by a submerged object. While taking a bath, Archimedes watched the water sloshing upon to the top of his tub, and in the excitement of his discovery, he ran through the street naked and shouting Eureka! Eureka! As a mathematician, however, Archimedes was able to outdo even his own accomplishment in physics. He was able to estimate the value of P to a remarkably precise value and to calculate the area underneath a parabolic curve. What's truly amazing is that he made these calculations using techniques surprisingly close to ideas from modern calculus that were invented about 1,800 years later. Archimedes calculated P and areas under curves by approximating them with straight edges polygons, adding more and more refined shape so that he would get closer and closer to the desired value. This is strongly reminiscent of the modern idea of an infinite limit. As far as his mathematical sophistication was concerned, Archimedes was nearly 2 millennia ahead of his time. So the third mathematician is John Napier. While many of the mathematicians on this list made contribution to a huge number of different fields of math, John Napier created one incredibly important concept, the logarithm. The logarithm of a number, roughly speaking, gives us an idea of the order of magnitude of that number. In modern terms, logarithms have base, and the logarithm of a number gives us the power we need to raise the base to get the number. For example, the base 10 logarithm of 10 is 1, and the base 10 logarithm of 100 is 2, since 101 equals 10 and 102 equals 100. One huge reason the logarithm is so useful lies in some of its properties. Logarithms turn multiplication into addition, and division into subtraction. To be more specific, the logarithm of the product of two numbers is the sum of the logarithms of the numbers. And similarly, the logarithm of a quotient is the difference of the logarithms. This is especially in the pre-computer world, makes calculation far easier. Multiplication and division algorithms for large or very precise numbers take much longer than addition or subtraction. So if someone had to multiply together two large numbers, they could look up the logarithms of the numbers in a table, add those, and then use a table from that sum to get back the result. Devices like slide rules also take advantage of logarithms. To allow for quick calculation, the speed up of calculation had very useful application in science and navigation, in which large numbers of calculations had to be done very quickly. Many quantities that vary over several orders of magnitude are measured on logarithms scale, like the Richter scale for earthquake and the decibel scale for loudness. So those are the mathematicians and their contributions. Thank you.